I work at this pokey little tech company called NPM. Has anyone ever heard of it? Has anyone not heard of NPM? All right, I'll give you a really quick intro. So NPM is this package manager. It's for JavaScript. A lot of people think that it stands for Node Package Manager. It's actually just 3 letters. It has no prescribed meaning at all. But it is a package manager, and people use it a lot to build cool applications and all those good things. And actually, even calling it a package manager for JavaScript is a little bit of a misnomer, because there's more than just JavaScript in there. We've got some CSS. Some people have thrown in some Go. I think someone snuck in a bit of Rust the other day. There's some C++ in there. So really, it's just a package manager, but it's a pretty good one. So what my job at NPM is I'm the engineering manager of the services team. Now, the services team encompasses everything from the website, the registry, the enterprise product, operations, making sure everything stays up all the time, and docs. So my team oversees a lot of stuff. And actually, the entire engineering organization does a lot of work to make sure that you all have the nicest, most wonderful experience using NPM. So with that, we've written a lot of code. And in fact, we've rewritten our code more than a few times. So what that means is we know bad code. And so recently, every week at NPM, we have an engineering all hands, where everybody on the engineering team comes together and talks about something. And it's just kind of like a fun, we have a very distributed team, so it's one of our few opportunities as a group to really come together and talk and be like, oh, wow, hey, human who lives like multiple time zones away from me, let's all hang out and chat. So anyway, I was thinking about this keynote, and I was like, it'd be really fun to give like a technical talk that it wasn't too technical, but still kind of technical, and technicals are always good. So why don't we talk about how bad code can be good? Because who's ever written bad code? Excellent, good. So this will be fun. So we sat around and we talked, and I was like, look, I need help writing this talk, so I'm just going to use all your brains and then have you write it for me. So the first question, of course, is, what is bad code? Now, I'm going to show you some samples. I have gotten permission for all of these code samples. They either have been or are currently in production. But that's OK, because this is a learning experience. All right. So there are 3 major categories of bad code, right? Like, there's functionality, maintainability, and readability. Now, the reason why I call these the main categories of bad code is that because for any good code, I think these are the 3 major tenets of good code, right? Like, you want your code to be functional, it needs to be maintainable, it needs to be readable. These are all important things. So if it doesn't do one of these things, it's probably not the best code ever. So let's dig into each category, right? And I'll show you samples, and you'll all laugh, and it'll be OK, because we'll all do this together. All right, so let's start off with some functionality. What is the purpose of functional code? Well, it's kind of just the job that it's supposed to do, right? So you want to, for a good piece of code, you want it to do code things, so it needs to be functional. All right, so what's the first major thing when you think about bad code? I think about supervillain code, right? Like, this is the morally, ethically bad code. Now, unfortunately, or fortunately, I think this is actually fortunate, we don't have any morally bad code in the NPM code base. I've checked. This is a good thing. But we do have this one comment. Here's a nice big block of comment where we're basically trying to prevent somebody from putting morally bad code. But essentially, what is morally bad? It's let's say I'm a hacker and I make a package that does something evil, TM, and then and then I get all of their bank account numbers and get super duper rich and become a VC and create LinkedIn for cats, right? Like, that's like morally bad. That's like super bad. Don't do that sort of thing. Other examples, of course, include viruses or password hijacking or all sorts of those things. Like, that's like bad code. English is such a wonderful language because one word can mean so many different things. But really what we're trying to do here is we're talking about bad code as in not great code. So when we're really thinking about functionally bad code, we're thinking about code that doesn't really do the thing it's supposed to do, right? So buggy code or just doesn't really do what it's supposed to. So here's an example of an integration test that was on the website. This is gone. So what does it do? It's called packageredirect.js. Fantastic. OK, so the purpose of this test is to ensure that when users go to npmjs.com/package name, that they actually get redirected to npmjs.com/package/package name, because that's where all the packages really live. But it's hard to remember that. So when you go to /express, it should take you to the Express package page. So why is the test called user with feature flag gets to the new org creation page? So FYI, we have a product called organizations. It's so that you can manage packages and teams and all of that good stuff. And so that this is important, we created a brand new org creation page, and we should ensure that you get to, except that this is the entirety of the file, packageredirect.js. So it's a little bit weird, and especially when you look at what the actual code does, it goes to the URL of /express and then waits to make sure that express, the package name, shows up on the page. So the code is doing what the file name says, but the name of the test is, OK, this is bad. All right. So that's bad, right? It doesn't do what it says on the tin. That's not good code. Another situation is when you have security risks, right? Like, that's probably not so good. But the last thing you want to do is to open up yourself or your users to bad actors with morally bad code, right? We talked about what morally bad code looks like. Here's an example. This is static page rendering code. So if you wanted to go see like our policies page or whatever, it's just static text. We talk to GitHub and then cache all this information. So this is the code in question. And you're like, OK, well, this seems OK, right? I mean, it's just a URL, and we're just going to fill it in with a couple of variable names. It's fine. Well, here's the thing. The type is system set. So we control that within our code base. But then the name is actually user set. And that can cause some issues. So ideally, you have something like, OK, well, let's go to the new dub repo and the policies.md. And that's fine. That's exactly the way it's supposed to work. But if you were thinking about it a little bit more, you could actually create a situation in which somebody goes to new /master/... corporate secrets / all the passwords, right? And I'm not saying that we have a file called that, but I mean, technically, somebody could hack into something that they maybe shouldn't be allowed to see. So that's probably not very good either. Now, one thing that I know I do a lot, because writing tests is a pain, and everything always works perfectly the first time, right? Right? Is when you forget to handle edge cases or error states. Maybe you have and as a result, you end up with a half-completed system or an incomplete component, right? So for example, here we have some old website code for browsing packages by keyword. All right, pretty cool. So we look up packages based on who's logged in. We list them out. We chunk them out. We paginate. And then we send it off to our view. And that seems totally fine, right? But what's wrong with this code? Well, what if something happens? What if there's an error? We need to catch that error, right? So whether you're using promises or callbacks, I don't really care. You do need to make sure that you manage and handle your errors, because otherwise, something goes wrong, and then your user goes where? I don't know. So that's maybe not the greatest code either. OK. So that's all like different types of things in terms of functionality. So let's talk about maintainability. So functionality, things do what you expect them to do. Like, it actually makes code do the thing. Maintainability is so that you can create a nice, steady, stable platform on which to build more code, right? So when do things go a little wonky with maintainability? Well, hopefully we've all heard of spaghetti code, right? And spaghetti code is this massive jumble of code that there's no real clear flow control. Maybe there's obscured state. You don't really know what's happening and when. So here's actually some code in our validate and store. And what this does is it allows a user to unpublish a package. So what's going on here? There's a lot of code kind of all at once. But in particular, you're seeing like the different then blocks. Some of them don't have returns in them. So what happens? I'm not entirely sure. What's the context being passed between the different then blocks? Again, not really sure. It does stuff, though, so you can unpublish packages sometimes, I think. But when we get a call from support saying, hey, I've got somebody saying that they can't unpublish a package within 24 hours, and we explicitly state that we can, there's a bug, well, we have to go back into this, and we're like, oh my goodness, what is going on here? And usually what this means is we're probably going to have to just scrap it all and start over. Like, if you have to completely refactor your code before you can start to add more on top of it, it's probably spaghetti code. All right, then you also have a situation where you have code with unknown side effects, right? So what does this mean? It means that you have to chase through the code base to fully understand where things are happening when they're supposed to. And side effects are all about truth in advertising. So for example, here we have some code for authorizing the publishing of private modules. All right, pretty cool. But this function is called check cache. It's a series of functions all put together, cool. So you get access, and then you create a package as part of checking the cache. So I think a lot of people do this by accident. They're like, well, you know, I need to check the cache, but before, if it's not in the cache, then I should probably make sure to create the package. But why are you creating the package in the function called check cache? It's false advertising, right? So when support comes in and says, oh my goodness, something's not quite right, and you're like, okay, well, something is going wrong. Like, for whatever reason, we're creating packages when we're not supposed to. Where are you going to look? Are you going to look at the function called create cache? Or check cache? Probably not. So false advertising, this is maybe not too great. OK, this is a side effect, right? All right, so that's all the fun stuff in terms of maintainability. Now, here's my favorite one, readability, right? So we have functionality where we're like, all right, gotta make something nice and functional, making sure it does what it's supposed to. Maintainable, it needs to have a nice solid foundation so we can add more things onto it. Readability is about being nice to yourself and to your future self and to all your coworkers, new and current, who might have to come back and look at your code. And so you think about it like, oh, it's not that big a deal, but it really kind of is, because if you want to be nice to your future self, I mean, how many of you have ever left for 2 weeks and then come back to your code and go, wait a second, right? Like, what? OK, so this is that category. All right, so one thing is that I know developers, whether they're newer to the industry or seasoned veterans, tend to do a lot, is they write this super clever code, right? You're like, wait a second. This code is 16 lines long. I bet I can make it into 5. Yes, right? Here's some code about, like, it transforms data for browsing packages. This is old code. This looks fine, right? It's a nice short function. It's 26 lines. That's pretty neat, right? What's going on here? It's a ternary inside a ternary inside a ternary inside a ternary. If you don't know what a ternary is, good. Right? I mean, it's basically just if, then, else trees, all wrapped up into funky punctuation. And you're like, what is going on here? And like, yes, OK, this could have been 10 lines, and it's only 4. Great. But if I need pen and paper to figure out how this works, and it takes me longer than 10 minutes with pen and paper, maybe it's a little too clever. So it's not easy for somebody to come back in and go, oh my God, I can add to this, I think. No, no, bad, OK. Or maybe you have something that's just a little too long for context, right? So in this case, so I think, yes, I come from NPM, and so I'm all into the many small modules sort of thing and like nice tiny pieces of code. But really, if you can't consume and maintain the state of your tiny function all in at once, then maybe it's not so tiny. For example, this is the function that we use, or that we used to use, to get information for an organization page, right? So like you go to /@npm corp, right? Like org/@npm corp, and you can see our org page, right? This is 150 lines of code in one function. I have a 13-inch MacBook Pro. This is pretty standard. If I have to go multiple scrolls just to get to the end of the function, maybe it's a little too long. And what does this mean, right? It means that every time you want to come back into the code, you're like, wait, did that happen at the beginning, the middle, the end, the beginning middle, the middle, the end middle, the end middle? I mean, like, what? That is ridiculous. So maybe it's too long, and maybe it's not too readable. And then this one is, really common. This is what people talk about on Twitter a lot, right? Like style standards, particularly code style, right? OK, so here's one of my favorite pieces of code in our code base. We have a Slack team at NPM, and we have a Loudbot. This is some of the code in Loudbot. So let's break this down. What's going on here? Well, first of all, we've got tabs instead of spaces. Goodness gracious. And not only are they tabs, they're 4 space tabs. I mean, who writes 4 space tabs in JavaScript? 2 spaces, thank you. Then there's this weird new-lined curly bracey thing, like, what is this, C++? Then semicolons, and then hanging semicolons. What is that? Like a whole line just for a semicolon. Yeah, no. No. There is nothing wrong with this code. There is absolutely nothing wrong with this code. It works beautifully. It does exactly what you need to do. You can actually go back through it and add more code to it. It's maintainable. It's functional. It's readable. Just because it doesn't match the style that you like doesn't mean it's bad. Style is personal, right? I'm not about to come in here and be all like, y'all, black is so last year. Ew. That's just rude, right? That's super rude. Also, black is the best color. So arguing about style, whether it's semicolons or tabs versus spaces or whatever, that's just rude. Just stop it. If anything, use a linter and get over it, right? If you don't know what a linter is an automated system. Let the computers do all the work for you that analyzes your code for potential errors, right? You can either have it autocorrect for you, or it can just simply warn you, whatever. Code the way you code. I don't care. That doesn't actually affect anything. Just make sure it's functional, maintainable, and not too long, and all sorts of things. OK, so that's, in a nutshell, some aspects of bad code. So we know what bad code looks like. That's kind of, OK, gross. So how do we minimize it, right? Because we want to be good JavaScript developers. We want to be writing good quality code. So we know what bad code looks like. Now let's clean it up. All right. So to start, let's talk about some common code smells. Beyond everything that I've already told you, here are a few more things to watch out for, but I'm not going to go into quite as much detail. Lots of advice here. Dig into each of them separately. All right. So you've got many branching paths, right? That's probably not a good thing. If you've got lots of ifs and elses, too many ternaries all nested into one, if you've got switches or whatever, maybe that's not the greatest thing to do. Maybe that'll add to some maintainability issues longer term. Or maybe you have some context-dependent understanding. If somebody is coming in from outside who does not know your code at all, and they can't give you a solid code review, maybe things are a little bit too complex. Or in addition, weird or long variable names, right? If you're thinking about the situation in which it's false advertising in terms of your names, that one piece of code could have been changed to check cache and create package name if necessary. That's a really weird long name. Don't do that. That's probably a sign that things are a little bit too complex. Similarly, the works on my machine approach, that's maybe not the most stable and greatest bit of code ever. There's always the not invented here syndrome. In particular about not invented here. Yes, I'm coming from NPM, and I like modules and all of that good stuff. But it's also important to remember that if somebody else has already written that code and created tests and thought about all the edge cases, chances are that, especially if they've got multiple contributors and they've got multiple version numbers on it, they're probably a few steps ahead of you on that one. Let them write that code and just use it. Benefit from it. Take the time that you would have taken to rewrite that code and find all the bugs yourself to do other things. Just to think about. And of course, if you know it's going to break, it's probably going to break. So that's a good code smell too. If you're like, yeah, this is terrible, this is going to break, that's a code smell. Get rid of it. OK. All right. So these are all like some code smells. It's like, stinky code, time to like take out the trash sort of thing. But how do we avoid these code smells? Well, I'm going to tell you what we do at NPM. We do a lot of pair programming, a lot of pair programming. And our team is really distributed, so we use, what do we use? We use Screen Hero. Thank you. Screen Hero, which is really, really great. To me, it is like the best distributed pair programming tool out there. It comes with Slack. So if you are on a Slack team, if your company pays for a Slack team, you have Screen Hero by default. So it's really great. It means that we have one person who drives and the other person who watches over their shoulder, well, through their computer screen. And it's really great because as you're coding, right, let's say you misspell something, or if you start creating this variable name that's like 700 characters, then the other person can be like, really? Is that necessary? And so it's a good way to have somebody else catch it before like a full-fledged code review. So then also commit early and often, right? In the same way that we create many small modules, I think it's good to have many small commits. With each tiny commit, you can actually see these are the things that I've created. Now, if your commit is like 150 lines in a single function, you can catch yourself really easily that way. Now, whether you commit early and often, like small commits all at once leading up to your pull request, or if you kind of make this huge commit and then right before you create your pull request, you rebase and then create nice and little things, like that's fine too. Just make sure that your tests always pass at the end of with each commit, so that if you have to do some funky Git things, you can always make sure that everything's passing. All right, that said, write tests. Write tests. Who here doesn't like testing? Yeah, I know, it's a pain in the butt. But it saves your butt so many times. Just said the word butt 3 times in a conference talk. That's pretty cool. All right. But the thing is, if your tests are too hard to write, right? Like if it's like too much effort, you're like, this is really hard to test, that's a code smell, right? So you can go ahead and like be like, all right, well, this is really hard to test. Maybe I should refactor. And then, of course, use a linter. Like, no, really. You should never spend more time arguing about things than to just make the original decision to compromise. We use standard at NPM. I love semicolons. Standard's like, semicolons, bye. And so I think when everybody loses a little bit, everybody wins. So yeah, OK. And finally, code reviews. At NPM, we really care about our code. We care about code quality because we know how many people depend on our code to do their jobs every day. So we take them very seriously. One thing is we never, ever merge our own pull request. You can merge it after somebody else puts a little sheep on there. I realize that New Zealand's all about sheep. But ship, like to ship code, it sounds a lot like sheeping. So we just put little sheep instead of the little ship it squirrel. It's an NPMism. Adopt it. It's cute. OK. Now, when you're doing a good code review, there are 3 major steps. And if it sounds like it takes a long time, it's because it does. The first thing is to do a holistic code review, or a holistic overview, right? And so you're like, OK, so I've got all the code that's about to be committed and all the code that currently exists. Are there tests for these bits of code? Is there anything that's about to clash in all of this? Let me make sure that all of it makes sense from like a high level. Then I'm going to go through commit by commit and make sure that each commit is doing something important or sensible. Sometimes you can catch just within the commit itself, like, oh, hold up, you're doing a little too much here, or this makes no sense whatsoever. And then while going commit by commit, I also go line by line. And I make sure like there aren't any spelling mistakes, or maybe this variable name is too long, or there's a callback pyramid of doom. Whatever it is, I go and I go, wait a second. And like I said, this takes a while. Careful consideration does take time. But what it means is that later you don't have to go back and go, wait a second, what was I doing here? And why did somebody else commit it? So like the thing is, when doing a good code review, you also create accountability across your team. That way, you're not the only one responsible for your code. Your entire team is responsible for the code. And that's, I think, the way that it should be on teams. All right, so that's how to kind of clean up some code. But when is bad code good? And this was the original question that I posed to the entire NPM engineering team the other day. I was like, can bad code be good? And the first thing that really stuck out from that conversation was when our CTO said, the beauty and horror of code is you get to see how other people think. And what I love about this is that regardless of whether your code is good or bad, the beauty of code is that you get to really see into someone's brain and see the way they kind of solve problems and the way they think about things. And that, to me, is really beautiful and really cool. And so, again, whether it's good or bad, we start to understand other people better when we look at their code. And especially when they write bad code, then we can be like, wait a second. Especially when you're first starting out, you don't necessarily know that your code is bad at the time, right? Like, how many times have we written bad code that we didn't realize was bad until like 2 months later when we come back and go, wait a minute, I can't write a test for this. This is terrible. I need to refactor. Whoa, you just learned something, right? You just learned when you need to refactor something. And so maybe in the future, you're not going to write code that way again, because refactoring takes time, and it's a pain in the butt. So you're still learning, which means that bad code is a learning opportunity. It's an opportunity for you to get feedback from your tools to make yourselves better. For more experienced devs, sometimes you write bad code because you just need to make some code that works. Just good enough code, right? You know it's going to get scrapped eventually. Who cares? Sometimes you just need it to do something. The perfect is the enemy of the good, right? Like, you just need to ship something, or you just want to do something exploratory. You just want to kind of play around. Fine. And sometimes we send signals to ourselves. We're like, this is going to need to be refactored, but I can't do this right now, so I'm just going to make it just work. But this is going to fail at some point. And when it does, I'm going to come back when I have more time, more energy, whatever, to go ahead and fix this. You know you're going to be throwing it away, so you just go ahead and do it anyway. And now, when I think about bad code, I'm often reminded that there's more to code than just the code, right? When we think about modules that we use, how many people, when you start using a new module, do you actually go in and look at the source code? It's not very often, right? As long as it has a good enough API, like nice enough interface, and nice enough, like the tests all pass, you're like, that's good enough for me. But sometimes if you look underneath, oh gosh, it's scary in there, right? Like, a lot of people use Express. Just going to leave that there. But the thing is, when you're looking at code, sometimes you need to actually run the code before you judge it, right? So I'm going to show you my very first bit. I'm going to show you a snippet of my very first bit of JavaScript ever. Now, here you're going to see the little hanging new line curly brace things. This is very context dependent. You need to understand what all of this stuff means. There's more than a few parameters that are being sent through functions. It's kind of gross. I get that. When I first started in this industry, I said, hey, I want to work on the internet. How hard can that possibly be? JavaScript? I'll learn some JavaScript. I was like, you can actually see in here that before this, I was writing C++ and Python, right? Like, there's some weird underscores and then all sorts of things. And I was like, JavaScript, how hard can that be? No big deal. I submitted it for a web dev job, and I got immediately rejected. They were like, yeah, no, not a chance. Let me show you what happens when you actually run this code. This is a fully articulated, three-dimensional hand. I was a roboticist before I came into web dev. Yeah, I know some of you are looking at the hand and going, ow, 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 ow. But the fact of the matter is, it's fully three-dimensional. It's actually really cool. I mean, it looks super janky. I get that. But hey. But I don't think they ever ran the code itself. And not to brag or anything, but I think I turned out OK. I'm working at NPM. I think my JavaScript eventually got OK. But when you reject people based just specifically on their code and just the style of the code or whatever, there's more to bad code than bad code. There's actual code in there that does something interesting. And so what that means is that bad code is part of our origin stories as developers. When we talk about this at NPM, we're all laughing really hard, right? Because it's like, yeah, I wrote bad code, and it was hilarious. I mean, it stunk at the time, but I mean, looking back, wow, I've learned a lot since then. And we've all done it. I asked you all, who's written bad code? Now, granted, I didn't ask who hasn't written bad code, but I'm just going to assume none of you exist. OK. And heads up, when you change languages, you're going to start over, right? And OK, yeah, that varies with experience. When you're first starting, like if you have only ever written one language and then you move on to the next language, chances are you're going to start over with kind of like bad code. But as you get more advanced and more experienced, you hit this point where you already know how to code in like 7 different languages. You understand how code works, and you know what bad code smells are. You're just learning syntax. And what you saw in my code sample was not bad code necessarily. It was just accented code. Just like when we when we learn a new foreign language, we speak with like an accent. We code in accents too, until we sort of started to learn and become more fluent in our new languages. So keep that in mind. So all right. All of that was good, right? Bad code can be cool. But what's wrong with bad code? We talked about what bad code is and how to minimize it and when it can be good for us. But it can also be bad for us. And here's where things can kind of start to go sour, right? We mock bad code. We make fun of it. We're like, look at that bad code. It's terrible. And it becomes this like institutionalized behavior where it's like OK to make fun of bad code, and then we go onto Twitter and we're like, that's terrible. And somehow we've come into this mentality of thinking that it's part of the process to become good in this industry. It's like, yeah, well, people made fun of my code, so I'm going to make fun of your code too. But what happens? Over time, beginners become terrified of pushing anything into any public sort of domain because they're scared. They're like, people are going to make fun of me. And I see this on Twitter all the time, and I see it on GitHub all the time, right? Like, we end up creating this like weird, gnarly cycle of trying to weed out people who are too sensitive. But you know what? You can have the thickest skin in the entire world, and when somebody tells you that your code sucks, like that stinks. That's really painful. And what happens is we start to develop this unhealthy attachment to our code, right? We either like fall into the camp of like super stubborn, where we're like, you know what? This is my code, and I'm never changing it. And I am the deity of this code base, and you will never, ever touch any of it. And if you want to change anything, you have to go through me, and this is my code, right? Or you fall into the other side of things, where you start to like really self-identify with the code, right? And you're like, but this is my code. How dare you like mock it? And you're mocking me. This is my code. And it becomes this source of shame, right? And you're like, oh my God, like, you hate my code. You must hate me. And I'm, oh. Code is just zeros and ones, y'all. It's a transcription method to make the computer do the thing. It has no bearing on you as a person. And in fact, I like to think of the art of code is that it is an act of communication to your colleagues and your future self, right? It's about improving communication across people to make the computers do the thing, because computers, whatever, they don't have feelings, but people do. And like any sort of communication, writing good code is hard. It's really hard. Writing beautiful, communicative code that is functional and maintainable and readable takes time and practice. So accept the bad code. It's OK. Bad code is good for you because it means you're going to get better. It's part of the process. So while you can't do it perfectly the first time, you can certainly get there slowly over time. At the end of 2014, I wrote a blog post called Code. And I'm going to read it to you. It's not very long. And you can go on to your morning tea. But I think this kind of sums up my feelings about code in general. Your code is not a reflection of you. It isn't a reflection of your beliefs, your upbringing, or your ability to be a good person. Your code is, however, a reflection of your thinking process at the time that you wrote it. Given our innate ability to change our minds, consider other viewpoints, and play with new ideas, why do we hold our code so dear? Your code can change. Your code will change. Your code must change if it's ever going to get better. So stop marrying your code. stop mirroring your code. The sooner you accept this, the happier you will be, and the better programmer you will become. Thank you so much.